Okay, so today's lab is a mixed exercise in stuff we've already done a little bit, but we're just going to perfect about using physical models, plastic models, as proxies for three-dimensional shape. But then I've also got a three-dimensional molecular modeling rendering software that I forgot to bring on the iPad. I've got a version of this that runs on an iPad. It's a cut down version. It's really simple because you can just poke the screen and flip the molecules around, but I put it on a laptop. So at home, people, you should have this one page that we're going to work through today. In fact, what I'm going to do is there'll be some writing on the board, so I'll leave it this way for now, but I might be moving the camera around as people do stuff. Okay. Let's run through the questions and then we'll scoot back and do them. Use model kit to construct all the possible constitutional isomers of C2H6O. All right, that one's going to be straightforward. Sketch the isomers as Kekule structures. Use the model kit to construct all the constitutional isomers of C5H12. Sketch as Kekule structures. Again, that should not be difficult. We'll be looking at branching there. C5H12 tells me that's an alkane. So nothing tricky. Use the model kit to construct all the stereoisomers of 2,3-butane-diol. That one's going to be harder to see because this is stereoisomers. We've just trained our eyes to look for those. Sketch the isomers as Newman projections. We can do that. And as Fisher projections. We don't know how to do that yet. On the other side, use the Spartan software to sketch CHBrCli. View the molecule in 3D. Determine if it is the R or the S enantiomer. Minimize the molecule's energy. Use the information to determine the bond lengths of the hydrogen, the chlorine, the bromine, and the iodine. And the bond angles. Use the space filling view to show the steric bulk of the groups. Sketch butane and view it in 3D, minimize the structure and record the relative energies of the staggered anti and staggered gauche conformers. Sketches and Newman projections, repeat for 1,2-dichloroethane, 2,5-dimethylhexane, and then sketch 1-ethyl 2-methyl-cyclohexane and view it in 3D. Do the cis isomer, minimize the structure and explain the positioning of the substituents. Perform the conformational analysis to measure the energy required for a ring flip to change the relative positions of the substituents. Okay, I know how to do all of that on the iPad software. It might take a couple of minutes to dig it out of the real PC software because everything on the PC is a little bit more hidden than it is on an iPad. So yeah, we can do that. All right, pens. We have a couple of different ways of showing the attachments, the configuration of a set of bonds around a central tetrahedral carbon. This Kekule structure only shows us attachments. It doesn't give us an absolute configuration. If I had 4 different groups, if this was a methyl and that's a chloro and that's a hydrogen and this is an ethyl, We cannot tell whether this is the R or the S. Cannot tell. Because this doesn't give me enough information. This is a wedge and hatch. And if I choose, remember we have to look at the bond down the, we have to look at this molecule down the bond of lowest priority. That's the bond of lowest priority. So if I draw that one pointing away from me, and then make this the chlorine and then the methyl. Okay, now I know 1, 2, 3. That's the clockwise one. That is the R. So this has more information embedded in it than this one does. Then there's another way of doing it. If I looked at my tetrahedron, now I've left my structures at the back, the little plastic models, but you'll have seen me already taking these and then snapping them together, right, to make a tetrahedron. You take a V and another V and you snap them together and you make a tetrahedron, which means two of the bonds point in the same direction. So if I've got two of them pointing out towards you, the other two will point away from you. This conveys as much information as this one. If I wrote, I'm going to mix this one up. Is that the R or the S? The very first part of the rule was draw the bond of lowest priority pointing away from you. This is pointing towards me. So whatever answer I discover is going to be the wrong answer. How many possible answers are there between R and S? 2. Whatever I find is the wrong answer. I'm okay with that. If I know that there are only 2 possible answers, yes or no, 0 and 1, R and S, on or off, then as long as I know what the rule is before I start, I'm okay with it being the wrong way around. So this goes 1, 2, 3, looks like it's going counterclockwise, looks like it is the S, looks S, but H is pointing towards, is not pointing away, so is actually the R. This representation is about to change. We're going to take that representation and simplify it. That's a Fisher projection. A Fisher projection. Can you see that at home? I'm not sure that I'm that far out. Oh, I don't know. This is a Fisher projection. It is different than the Kekulé structure in one really super important respect. It's missing the atom label. If, right, so this one is the, we've determined this is the R, right? If I write the carbon in the middle, that detail goes away. I can no longer tell if this is the R or the S. The Fisher projection has no atom label. Now contains more information. Okay. We've got the Kekulé structures, the wedge and hatch lines, Fischer projections, and then our other option would be a Newman projection. And this is 1, 2, 3, 4 carbons in a row with the chloro at the 2. So I would rewrite that probably the most interesting way is to pick which of these carbons to look at, which is the bond that's going to be doing the most steric repelling. Okay, that's big, and that and this are probably going to get in each other's way as well. So I'm going to want to look down that particular bond. The carbon 2 to carbon 3 bond is the most interesting bond in this molecule. So I put the chlorine here, the methyl there, the hydrogen here. And then I can't see that carbon, but I can see these 2 hydrogens and that methyl. Okay. So I now have multiple ways of representing the same molecule. I can write it out as a Kekulé structure, I can write it out in this tetrahedral form, I can write it out as a Fischer projection, I can write it out as a Newman projection. Okay, all right, break out the little plastic models and get going. It's a lab workshop setting. I don't think that everybody should start at question 1 and progress through. I think that you should nod and wink at each other and divide the task and conquer the tasks. People playing at home don't have the plastic models. And there's a camera in the room. That camera always points this way. And turn the microphone off. Okay, people playing at home, you're going to be part of a virtual group who will make models on the desktop somewhere by you. If I switch the camera off, I get to refocus it. So I'm going to switch it off for a second and then switch it back on again. So somebody should occupy the front bench and kind of work in this space. Nicole, just move to the front.
Do you mean that's one if you want?
Were you right in front of him?
Yeah.
So that is the only thing that's on camera right now. You'll see your hands, but you won't see your face, you won't see anything. And you'll, like that, you're comfortable with that?
No worries.
Are you comfortable with that?
No worries. Absolutely.
Okay, and while that is happening, so, you know, divide and conquer, share your findings. When it says produce all the structures, that's why working more than one brain is going to help. And while you're doing that, I'm going to fire up the software and see what we can do. And then we'll take turns. Using this.
The second one? Okay. It's so not organized. Oh, that's easy.
I might have to move the blast shield a little bit. Right. Okay.
There's no, I can
Not sure.
The software that I'm going to show you today recently went on a price reduction. It's now only $750.
Ooh,
Yeah.
perfect.
If you're a student, you can buy it for $50. If you're a student, they will sell you a copy that will expire in December for $20 for a laptop. And it's insanely powerful. You can also buy the iPad app for about $19, whatever it is. They don't look like tetrahedrons to me. Which is a bit of a, one of these kits. So you.
It's just hard to find the, oh, I get it.
This.
See, I had to find like specific items.
That's a tetra. Let's put this. This is deceptive. Can you see that those are different sizes?
Yeah.
They should never have made these black
That's what I want.
because our eyes are looking for the dark black ones or the charcoal gray ones to be copies. This is not a tetrahedron. It is bigger because it's buried in that one.
So it's the smaller.
Let me go check.
I didn't realize how much technology looked like an animal.
It does.
And when I did, it's like,
It's like a
creature.
Is bigger.
Alright.
Wait,
What
no,
for ethanol
it's
are they?
like-
That's a real question. Well, not for ethanol, but for CTH6.
Two.
Because you move your oxygen to any other spot,
Yeah, so it's
and it's still ethanol. It doesn't change.
I don't even know.
So is that the only constitutional
They should
oxygen?
have made that the same.
Because I think about it, I move oxygen here,
Yeah.
here,
These ones
here,
have
here,
kind
or
of.
It's
here.
done.
It's still in one position,
Yeah.
so it doesn't change anything. I think that's the only one. Because even if we do something as small as,
So you need
like,
two
that,
carbons, 6
like that,
hydrogen, and
that
oxygen.
wouldn't even be like the isomer that we learned
And
yesterday.
the oxygen is also.
Because you can still mirror how you have to do.
So what you gotta figure out is how can I put all
It's
these together?
Yeah, because of all
So
the.
just copy the right number.
It feels wrong because there's only one of them. Like, you just think that there's like 12,
Yeah.
but
Only be one space left.
All right, so I'll make a
yeah.
Is it all the first one?
Yes, but those are
Six hydrogens.
I'm confused. Because don't you just want me to show?
Yeah, I think you
That's why I said.
You're hiding the answer. Yeah. Okay, that's one possibility.
It looks like a dog.
Using the. Yeah.
That's what
No. So it turns out that the bonds between carbons and hydrogens are short, and the pink bonds are best suited for the short bonds.
So you watch me do all that?
It's okay, it's all right. So this is the same as yours, only it's a little bit.
Mine looks like a dog.
So this and this are essentially the same thing, the connectivity is the same. Only
Yeah.
these bonds are a true activity. With that bond, you're like, reason is,
I get you now.
Yeah.
and you've got all your bonds being the same way.
So we're all on the same.
Okay, all right.
Yeah, I think that's the only one.
that right?
So you two came up
It's
with
so weird.
an answer.
Well, this is the.
Oh. It says, use model kit to construct all. All, so sketch that one, because yes, that is one of the answers. And if you guys are not doing question one, you can turn around and look. I'll put this on the camera. Yeah, it looks like. Okay. So question one was sketch all of the structures for C2H6O, and everybody came up with the same answer. The pink bonds are shorter than the white bonds because bonds to hydrogen are shorter than bonds to carbon. And so this is a little bit better of a representation than this one, but no harm done. Everyone came up with the same answer. Now, if it said, use the model kit to construct the structure of C2H6O, you'd be done. But it doesn't. The question says, write them all. That's something else. That's for
Oh.
just as a calculator, yeah. Okay, just to show the connectivity.
Probably should have taken this apart before I drew it. It's fine. Okay.
There is something missing. There we go. There's the other one. Oxygen always has 2 bonds. Carbon always has 4 bonds. Carbon always has 4 bonds. Hydrogen always has 1 bond. This is C2H6O. Lone pairs of electrons on the oxygen.
Can I get you, that's.
Yes.
My mom's.
Yeah.
And so then I see.
Oh, really?
Yeah.
Oh.
Excuse me? Okay. Yes,
Can't
good.
even solve it.
All right, now your oxygen has 3 bonds. So fix that. Oxygen's only allowed to have 2.
No, that was.
Okay. Does this work? You always sing the last thing we heard on the radio before you get out of the car.
Yeah.
This morning it was a really annoying 90s techno pop hit.
This is a 7-1.
Fantastic.
Repulsion. This is,
Just complete.
yeah. No, so,
No.
All right, people, here's the first isomer for number 2.
I don't know how to do this.
Okay.
Okay. So question number 1 is straightforward. They get a little bit more complicated. All right, let's see what we've got.
I'll change it.
we can change this.
So 1, 2, 3, 4, 5. Question 2 is C5H12. C5H12 is clearly an alkane because 5 times 2 is 10 plus 2 is 12. So 12 hydrogens for the 5 carbons. That's where you start. The next obvious thing to do would be to take off a methyl and move it. Wow.
2-methylbutane.
And you make 2-methylbutane. And then move that methyl down the chain and make 3-methylbutane. Oh, wait. 3-methylbutane is 2-methylbutane. So you're done with the butanes, which means it's time to go down a carbon. Oops. And see if you can make sense
Wait a second.
of that.
I can't go on it. Somehow, however, let's see what happens. Let's see what happens.
And what have you made?
We still got, longest chain is still 3, so the 2 dimethyl propane.
Okay.
Sweet. 2 dimethyl propane.
Yeah, that's it. I should.
Yeah. You know, it doesn't, I just realized that in the instructions, it doesn't say you have to, but
So.
Sorry.
propane.
Wait, I don't know.
1, 2, 3, 4, 5. So, yeah, that's your nth aim. how many ISOs you have that
I'll be honest, that's probably one of the most satisfying markers. I
That,
love that so much. It just makes me happy. Like, I just look at that, it makes me smile, you know, look, thanks,
oh my
sick.
gosh.
It's literally a helicopter. Yeah, it's fine, making it fun.
Yeah.
Just enjoying myself right now. That one now, because if we try to go down to ethane,
Yes, but it's also.
it's just not possible.
done.
Well, and technically, that's a methane right there. And the only way to attach the rest of the food were to put them on the same one, so it would just clean out the
You're right.
So that's,
That is really upsetting.
I'm just gonna watch it again.
although I don't,
Or put it here somewhere.
it's on number one, I guess I don't use it. Also kind of thinking about, yeah, no, you're good. It's good.
Too far away from the action. You sit here. That way, then you can do more of the collective.
Okay, number three, use the knowledge to
All right,
all sterilize.
I'm going to be right back.
What is the name of this? What's the name?
2,2 dimethyltryptamine.
So how do you do that?
So your longest chain is 3,
Yeah, right.
and then off of the second one in that chain, you have 2 methyl groups.
Okay.
Right, so it's dimethyl for that, and both of those are off the second one. So it's 2, 2 dimethyl.
Are we using like, for the multiple choice portion of the test, are we using a lockdown browser?
That's what he, well, I thought that's what he was, he never explicitly said that, so I don't know.
Yeah, he said there's just gonna be a time portion on the multiple choice and then a worksheet. So, and then since he didn't say anything about it. Let's see what tells the Johnny with the browser like.
It kind of made it sound like there was, but he never said that there was.
Really?
Yeah.
I didn't think he saw it.
Okay, maybe,
Yeah.
maybe I'm just reading
Yeah.
it.
Still
Okay.
listening.
Yeah, I wrote them as I was in grade.
Yeah.
And then I was supposed to spoil to either.
I thought it was pretty.
It was fine.
It was not what I was expecting.
No, that's true.
Yeah.
I was just.
So multiple choice, I was like, this is basic biology.
Yeah, there was like 3 that I was like, and then,
I like second guessing some of them, too, because it's so easy, I was like.
and I had to explain,
Well,
I had to explain the electron translate chain, and I was like, of course, like,
Yeah, I waited like for the free response last, because I was like, I might as well get as much questions as we got.
yeah.
And then I like went to that one like last, because it was on the beginning, right, because I was like typing it out, and I was running out of time, so I didn't finish it.
That was my dance.
So it wasn't a little-
I almost ran out of time.
Yeah.
Because I tried to explain everything in as much detail as I could.
Yeah.
Right, and then I got to the end, I had like 1 minute left. I was like, oh my God, I'm pushing time right now. Absolutely pushing time.
Yeah, it was.
Okay. What are we doing next?
Trying to figure out the dial one.
Yeah, this one's going to be a little bit more of a challenge. Diol just means two alcohols, and an alcohol is an OH. So it's a red dot and a white dot attached to it. So just build it. And then see if the one that you built is the same as the one that somebody else built. And yeah, and see if that just accidentally throws the answer up in your face.
2,3-butanediol. Okay, so you've got a hydroxyl
So
group
2,3-butane-diol, 4 carbons, bute,
in the 4 carbon.
with an oxygen on the 2 and an oxygen on the 3.
Maybe.
So this molecule's going to be symmetrical. Symmetry is a wonderful thing. It does all sorts of mysterious actions to our molecule.
I can never get these things.
So part 3, 2,3-butane-diol, you need 4 carbons in a chain, all single bonds. Alcohols on the 2 and the 3. So what we didn't say was the first molecule that you made, C2H6O, that was either ethanol, an alcohol. Alcohols have a carbon to oxygen to hydrogen set of bonds, or an ether, carbon to oxygen to carbon set of bonds, and the ether would be called methoxymethane, because the longest carbon chain in your molecule was only 1 carbon long. The longest uninterrupted carbon-carbon chain was only 1 carbon long.
That's what I'm working towards, yeah.
Okay. Let's start this one. Let's see if I can do that.
How do your glasses not fucking?
You have to, like, put them down so it kind of gets annoying. Sometimes it's annoying. You just can't breathe.
Yeah.
Yeah, no, breathe.
Just stop breathing.
Nicole, that's really bad advice, I'll be honest. Okay, oh my gosh.
So typically, I want to break this.
There we go. Now, presumably. Give it a classic shake, see what happens.
You try it all.
I was actually pretty close. Oh my god, okay.
This is the only structure.
Well, see, it's asking, it's giving us the,
I'm not.
rather than the chemical formula,
I
it's giving us
was,
the
and
small.
then I don't want to talk about it.
So, but it's got a stereoisomer.
I don't know.
So, but I'm not sure.
I'll be-
But it's not, it's stereoisomer.
I look at it.
We have to sketch it because I did this.
Yeah, so.
So that's required. You're missing something from our list of isomers, configuration, confirmation, optical, and geometric.
Yes.
But I don't have stereo. Am I missing that?
Stereoisomers are another way of saying optical isomers.
Saying what?
Optical.
Okay.
Good to know. All right, so presumably that's one.
So I can imagine it.
Yeah, I did that last night.
That's another, much less stable, but
Good times.
Look at that. Don't keep
Isomer is as Newman predicted. So I guess the most interesting one for us is the bond between 2, 3. Right? It's the bond between the second and third. Because if we're rotating around there, that's what's gonna make the most difference, right? The amount of resistance that's there, the repulsion that's there.
This is.
That's usually.
So I'm assuming it's 3. So,
Okay. Okay, anybody else? So collecting the diols.
Struggling right now.
I don't know if I've been.
Well, we'll see. I'm gonna pull them up to the camera. And make sure that it's looking, if they're still awake. Okay. So for question 3, we asked people to build 2, 3, 4, 2, 3 butane diol. This is an alcohol, carbon to oxygen to hydrogen. Carbon to oxygen to hydrogen is a diol, 2 alcohols in the same group. So this is 2, 3 butane diol. Somebody else built this one. It is 2, 3 butane diol. Somebody else built this one. It is 2, 3 butane diol. Were they all the same molecule? Oh. That and this. Okay, look at that. And look at that. They're the same as each other. That one and this one are not the same as each other. They're different at this carbon. So if I try to make them be the same at that carbon, I make the other one go wrong. Why is that? What is butane diol hiding from us? The other one, just as passing.
Oh.
The oxygen and the carbon and the carbon and the carbon line up. This oxygen. Why is that? It's not cis trans. And when I make these line up, it throws the other one up like a net. Here's what you do. With the plastic model in front of you, put your finger on carbon number 2. Count the number of different groups that are attached to carbon number 2 out loud.
1, 2, 3. Now I feel like I'm wrong.
Number of different group. Put your finger on carbon number 2. Count the number of different groups that are attached to that carbon. Out loud.
1, 2, 3, 4.
Just get one.
Well, I'm thinking, does that, because this is the same as that. I'm confused.
No, I'm confused too.
It is not tricky. It's as tricky as it's staring you in the face. That's how tricky it is. Okay, this is carbon number 2. Carbon number 2 is attached to a methyl, a hydrogen, an oxygen, and a carbon that's attached to another methyl and another oxygen. That's 4 different groups around a tetrahedral carbon. What does that make carbon number 2? We did it in class yesterday. Carbon number 2 is a chirality center. It is a point at which I can generate 2 different optical atoms. One is right-handed and one is left-handed. They are R and S. It is possible for me. Oh, so we jammed that in there really good.
I'm
So.
sorry.
Yeah.
I hate when they fall out.
To switch that around and make the other isomer with that line. That's the opposite isomer that I had to make by detaching the atom, moving it around, and then reattaching it somewhere else. So I have a chirality center at carbon number 2. That's going to generate 2 isomers for me, R and S. Put your finger on carbon number 3 and ask yourself the same question. Carbon number 3 also has 4 different groups. So chirality center number 3 is, carbon number 3 is also a chirality center, which means it will be generating R and S isomers also. How many possibilities is that going to generate? How many isomers will you have? 4. There are 4 possible answers. They are RR, RS, SR, and SS. You have 4 possible isomers. Now, the beautiful thing about this particular molecule is that when you make it like this, they're different. But when you make it like this, something extra special happens because this molecule is symmetrical. That molecule is symmetrical, right down the middle, like here. And when you have symmetry inside a molecule, the mirror image of something that has a plane of symmetry is the same as what you started with. If you drew a triangle and you put a mirror through the middle of that triangle, its reflection completes the triangle, because this had a plane of symmetry. If you put a square and you put a mirror right through the middle of it, so anything that has a plane of symmetry, its mirror image is itself. So you have 4 isomers, but 2 of them are the same as each other. Get to sketching. They are RS, SR, and SS, and we'll do it in class tomorrow. Okay, I am about ready to hook this computer up. If I can see it, I can't quite see the computer. Fold over. In fact, what I'm going to do, I can't stretch this way. I'm going to turn this around and have it face.
Oh wait, are you gonna draw it?
Yeah,
Okay.
but do you need that?
No,
Oh, it's ours.
That's all I was.
Take it, you're good. Except I'm breaking it, I'm trying to.
Because you got one too, right?
One of those. Okay. I'm just gonna. That was what I was.
Yeah.
Up top.
Oh, nice.
Oh, you think she'll reverse that?
No, like, I think it's hidden. It just reversed. It's like a hundred.
Yeah, it's the next thing.
Oh, I guess I just.
Well, I don't want to crowd you, but I'm going to sit here. And that's as far as that computer will stretch. Oh, no, absolutely. The classroom today. Classroom.
Okay. Throw it somewhere.
So that's one, presumably.
That's the.
That's just the most stable version.
Yeah, I was like.
I don't know if I broke it, but it's something wrong.
All right, I am moving on. I'm turning the page over, and I am using Spartan software. And I'm going to leave the desktop open for you to all come and poke at it when we have the iPad. Pass it around, actually. So, all right. Question 4 says, use Spartan software to sketch CHBR, CLI, and then do these operations. All right, let's look. In the top left of the picture frame, there's a little icon that if you hover over it, it says build. I click that, and it gives me a page. On the right-hand side, I get to pick what type of atom I want to add to my structure. I'm going to put a carbon on the page by double-clicking it, and I'm allowed to rotate that carbon. There it is, a tetrahedral carbon. I picked from the list, it said sp3 somewhere. And now I'm going to add atoms to it. From this part of the model kit, I'm going to pick inorganic, which is going to give me access to the entire periodic table. And on the drop-down menu, which currently says carbon, I'm going to pick hydrogen. And it has added a hydrogen. That should only be a monovalent hydrogen. Don't know why it does that. So I'm going to scrub those extra valences off. Okay, we're going to go back to the periodic table. I'm going to find a bromine. I'm going to add the bromine. I'm going to go back to the periodic table, and I'm going to add chlorine. And I do that by finding one of these yellow bonds, which is an available valence, pointing directly at it, and then double clicking. And then my final atom is an iodine. There you go. And this is just a little ball and stick representation of what we think the molecules should look like based on the length of bonds. Bonds to iodine being longer than bonds to bromine, being longer than bonds to chlorine, being longer, much longer than bonds to hydrogen. If, very, very bottom right, if I click this icon, which has an energy profile pointing downwards, it will perform an energy minimization and tell me at the end of it, down here in the bottom, this is my total energy for this molecule in kilojoules per mole. And now I can do a couple of simple operations on this thing. I can change the way that it's displayed. This model currently is what we would call ball and spoke or ball and stick. If I move to space filling from the model drop-down menu, this is how much space those atoms are occupying. Okay, there's a central carbon, and this big balloon is the iodine. This other giant balloon is the bromine. The iodine is giant, bromine is big, and the chlorine is big, and the puny little hydrogen right here with its little stubby bond. All right, we can actually measure those. I'm going to go back to ball and spoke because it's the most appealing. Geometry. I can measure distance, I can measure angles. If I want to measure distance, I click on that, and it will give me a hint all the way down here in the bottom left. It says, select 2 atoms or a bond. Let's try 2 atoms first. And I click on that atom, the hydrogen, and this atom, the carbon, and it tells me that the distance between the hydrogen and the carbon down here in the right-hand side, bottom right, is 1.09 angstroms. An angstrom is 10 to the negative 10 meters. An angstrom is 100 picometers, or a tenth of a nanometer. All right. I've shown you how to conclude. And then from that drop down, you can measure angles, you can measure distances. Take it in turns. Collectively share the data out loud. Chair is open. And then we'll progress through the other tasks. People at home, can you see what I just did on the screen? Maybe not. No. What do I have to do? No, that's not what I want. All right, short of pointing the camera at the screen, I don't know how to do that. Okay, hold on. Somebody needs to be sitting in front of the laptop. Oh,
Oh, I'm sorry, I'm sorry.
no, just click.
Then this is just the most stable version. Because when you rotate it 180 degrees, so it's perfectly symmetrical, like this, it's fully eclipsed, right? So if you rotate it 180 degrees.
So people at home, I don't know how to share the screen from the laptop that is plugged in. It's running through at our end, but it's not showing at yours, and I have no idea how to fix that. So yeah, you need to find all of those lengths and the angles. The way that we would write an angle is between 3 points. So you write angle. The angle between, carbon's always going to be in the middle. If you wanted to know the angle between the bromine, the carbon, and the iodine, you would write it that way. Carbon's always going to be the middle, because the carbon is the middle part of this molecule. Okay. So you would go up to geometry, measure distance, and then either pick 2 atoms or pick the bond, yeah, that's between them. And then it displays, that's twice as big.
Yes.
That is twice as big. That is 2 angstroms. So the distance between the carbon and the iodine is twice as long as it is between the carbon and the hydrogen. What do you think having a long bond means for the molecule?
For the molecule?
Yeah, long bonds, do they sound stable or unstable?
Unstable.
Unstable. Long bonds are weak. Short bonds are strong. Okay, just run through those. And let's kind of, there's plenty of, that can be your task. There's plenty for other people to do.
Okay.
Plus it gets progressively more difficult as the day goes on, so you should always volunteer early.
So I guess that's.
All right, and now the angles.
Mm-hmm.
So.
Click
Click
an atom on the outside,
Okay,
and then the atom in the middle, and then one of the other atoms.
so you said we can get this exact thing on
Only
like,
if you could try.
on an iPad.
Yeah,
We did like the.
yeah, there's an iPad app that is a bit cut down. It doesn't have all of the atoms in it. It doesn't have all of the calculations behind it. It doesn't have all of the databases. But for $20, it's amazing. And it works on a phone as well. It will work on your phone, but trying to draw a protein on your phone is kind of difficult.
Should we just draw out the?
So the iodine, what's that? The iodine to chlorine, sorry, the iodine to carbon to chlorine bond is 109.5. The ideal tetrahedral bond is 109.45, so it's only a little bit bigger spread out than a regular tetrahedral bond. So bromine to carbon to hydrogen was 106.3. That one is spread. Oh, that one's squeezed. 109. So the hydrogen is being squeezed by the big halogens that are around it. You're going to see all of the bonds, I think, that have a hydrogen in them be squeezed. So that's the chlorine to carbon to hydrogen bond is 108.4. Okay. When we've collected all of these numbers, we'll read them all out loud, so that people at home who are making a table, be ready with the table, can scribble the answers in. Okay, is that it?
Yeah.
Okay. Somebody occupy the seat. We're moving on to question number 5. So people playing at home, bond lengths. Bond lengths, carbon to hydrogen, 1.09 angstroms. Remember, an angstrom is 10 to the negative 10 meters. Carbon to chlorine, 1.77 angstroms. Carbon to bromine, 1.95 angstroms. Carbon to iodine, 2.08 angstroms. Bond angles. Hydrogen to carbon to chlorine, 108.4. Hydrogen to carbon to bromine, 106.3. Chlorine to carbon to iodine, 109.5. And bromine to carbon to iodine, 109.5. Okay, we're moving on.
Oh, I just drew it like that, so it'd be easier.
Where is this symbol for?
It's A.
It's an A with the loop on the top of the A.
Yeah.
So we're going to want a new build.
Exciting.
This one in the corner. Oh, no, just click that little icon and it can give you a fresh page. All right, so question 5 says, sketch butane, view it in 3 dimensions, minimize the structure and record the relative energies of the staggered anti and staggered gauche conformers. So, from you can just click to organic. It's going to give you a carbon. Click anywhere, double click anywhere in the box. All right, now put 4 carbons in a chain. There you go. So you built butane. The software is smart enough, you don't have to put the hydrogens in. It knows that the hydrogens are there. If you click this minimize, it will give it a bit of a jiggle. And this is now your energy. Your energy is negative 21.23 kilojoules per mole. If you click and drag, you can rotate that molecule around on the screen. Is that staggered or eclipsed? Is it staggered gauche? Is it staggered anti? Which conformation has the software given us as the best, most stable? When you minimize, it gives you the most stable shape for this molecule. What has it given us? That is staggered anti. And if you drag it around so that I can't see these two, one of these carbons is hidden behind the other one. Go ahead and see if you can drag that. It takes a second to get used to it. No, not quite. Keep trying. Oh, there. Oh, yeah. Okay. Now see if we can rotate that.
That way?
Giving it your all, 110%. No, I didn't.
It's negative 20. Is it not still on the screen? 20 something then. All right.
And that's the staggered anti?
Yeah,
Okay.
so you write down,
So here we go, 4 carbons in a chain. And I'm about to have carbon 2 and carbon 3 overlap, right? Can you see that?
I don't know.
That is staggered anti. If I go, so this is slightly different than the app that I'm used to fiddling with, where the energy just gets displayed, because I've got a short list. I should be able to measure that. Oh, you know what I can do is I can just do this. There you go. No,
So,
that wasn't it.
so
All right, so what I'm going to do now, or try, this is actually more difficult to do than it is on the app, is I'm going to take this central atom right there, that bond, and see if I can rotate around that bond. I don't have to do that on the full software.
Oh, I should have known, that's what he was trying to get it in, because we didn't write it down.
Got it.
Oh, well, you can just,
The first one was the staggered dancing, right? Or was it-
Yeah, it was a Saturday.
Yeah, the first one was the anti. Yeah.
I think it was like 21, negative 21.
Yeah, it's Saturday.
21.
Did you drop it, human production for it, or?
Yeah.
Or is it not?
Yeah. That's great.
I don't know how to constrain. So the energy was negative 21.23 kilojoules per mole.
It's just,
Yeah.
it's just,
It's
so
just like,
the CH2 carbon.
Move on, I'll figure out how to, because it keeps the last picture that you've used.
Would you agree with it? That's.
Yes, so draw your Newman projection of that, we'll move on, and I will figure out how to rotate around a single bond and come back and fix it.
That is going to be the intersection. So the group is coming off the top as well. And that's what we're talking about.
Somebody needs to take it to the next molecule.
The intersections, yeah.
That's actually.
Two bonds. Yeah, I'm looking at it. These are going to be hydrogens.
Yes, because I have that actually visual that way.
Yeah.
Let's see, in the back.
We did be good. Yeah, Nicole. Yeah, Nicole, you're doing it. You did it. Oh.
Nothing's moving. I can't even look at it.
And I didn't want to try and get it.
Just pretend.
What did you do? I just
Just-
took it.
Yeah, and then once it goes to this.
Hey.
Yeah, we're just breaking the computer, it's okay. Well, Nicole's breaking.
No, I'm not. Someone else did earlier. It started off broken.
She's breaking the computer.
The computer won't turn on. He's not looking, not my phone.
Okay, the computer's on, we're just like.
You're changing the picture, so that's what it is.
We're getting slideshow.
Yeah, exactly.
And this is where I went in Jamaica, you know.
Oh, that's not your backyard?
Yeah. This is where
That's
I
you.
served. That's me.
That's you.
Yeah. Her name is Cupcake. Yeah, this is,
Wow. Is that normal?
that's the party I went. Rumor City.
Gosh. 1, 2, I'm just gonna make this, it's so much easier.
Yeah.
1, 2, dichloroethane. I found it looks Is he coming?
Actually, I'm gonna try to set it over.
It's staggered here, this one, so like it'd be like this CH3 on one side, and then your projection
I swear that technology actually has a brain and they just hate it, it's being messed with. And so it just acts up. It's like an amateur child, you know, has attitude. I swear.
I use it for
Okay.
so bad. The last.
Hey. Okay. So. 1, 2,
Does it not work like at all?
dichloroethane.
Oh, it's because this just doesn't work.
You're doing so good.
That's probably what it is. Dang,
Okay,
okay, so
guys,
we
we're
know
gonna try
now.
this energy.
Yeah, they talk a lot. More than I
How
do.
is that funny?
Good question.
Oh wait, here, can I jump this?
Yeah,
for
Wait,
sure.
if I exit out of this,
Well, I can't.
because it showed up on this side.
Literally. We can always fix it.
Okay.
What if I click on it?
Oh wait. It starts.
Are you trying to make it first?
Can you click on roll or on? Okay, so what's it do?
Did you get a boost? Oh, yeah.
Or is it a geometry?
I gotta take that out.
Measure.
I lost the thing now.
I always leave my piercings.
I don't know any of these things, but I don't want to click on it.
Means a raise.
Yeah, I will.
Oh, yeah, click that, yeah. Alright, let's just go with it.
Okay.
That's a lot more.
Yeah, okay, go.
Because they lay flat.
How many was it? 4?
I want to get more piercings.
I want to go on Sunday. I mean, I want to
Oh,
get this one so
platinum?
bad. Yeah,
It's not bad. I have that one. I wish I would've got mine a little lower, but
lower. Yeah, I don't know where I want it.
like literally right under it.
Right under.
But I need to like even them out. Like I want to get two right here, like just on my cartilage. And then I need something in the middle right here, but I don't know what it'll be. Because I already have this and I don't want it. I don't want to do the same, I want to balance.
Yeah, I agree with you. You can always go like another one like right above it. I think like
Yeah.
three.
Got it, okay, negative 21.2379 kilojoules.
Wow.
So in your bag.
No,
Yes. Negative 21. 2379.
Oh wait, I didn't make it both your cartilages.
Yeah, that's right, sorry.
Oh my gosh, you got them at the same time.
Yeah.
Oh my god.
That's the exercise when I moved to
wait, how'd you get it?
That one's the easiest.
I just redid
It's
it.
the easiest one I've ever done.
Really?
It heals so quick. This one.
Okay.
For the stopping shorter, probably like 2-3 months, and then I've never taken it out for like an extended period of time, like I don't take it out for 3 months.
Yeah,
Just not ever did this one.
yeah.
So I would say probably like 8 months, like
Chlorine.
I just put Band-Aids over it. I put Band-Aids
When
over
did
this
you,
one.
when did you switch out? Or did it? did you
I
get-
got pierced with a hoop, but I got pierced with a silver ball. Like, you know, so one with the ball that just like sits in there.
Oh.
I think I switched up like 4 weeks.
Wait, can you get the hoop at Platinum? Like, is it-
I've never gotten pierced at Platinum, but I would assume. I got mine at Atomic.
it's on there?
Wait, how can I don't have like the chlorine to where I can put it in the.
30.
Okay, because I wanted to start off with the hoop, but I didn't know you were gonna do it, so.
Yeah, I always, the girl that I was at home, she always started off with
So
a hoop.
Nicole,
Really?
Yeah, I
know how it's gonna work.
Because I want to do the series, I don't know. Like, it's such a-
Yeah, no, I'm definitely like a gold, like, yeah, like, I have something different, I think I have that was like gold, like silver. It was really pretty. I just like hoops. I need to get a small one, because it gets stored when I sleep.
Oh, okay.
so I'm just simply what.
Because they said this one, that would be, I'm like,
It's based off of
These are
like.
soft from each other, or
I'm using it.
it's either that's good, this is easy.
Oh my god.
I like the way they look, like,
Yeah.
still,
Yeah, no, I love the girl I go to. I'm so,
Oh,
I hate
it's
myself.
based off
because
of-
I'm insecure.
Walk the side.
It's based off of size. It's not based off of mass, but it's based off size.
Okay, so then it would be the
would be methyl group?
Yeah, it would be. Okay, do y'all know how to make it to where like the chlorine has a bond coming off of it?
The chlorine,
Yes.
oh, right there. Wait, oh, right, no, that just adds.
Yeah, but it needs to like have a bond.
What does it need on the end of it? Hydrogen?
Yeah. I need a
Oh,
chlorine
right
that's
there. Above it, the H, you just click on the chlorine and then put the hydrogen on there? Or I don't know how this works.
no, because then it'll turn into two.
Oh.
Wait, maybe if I try, it's working in there.
And you can delete extra bonds too, like extra valencies.
Can you add the bond? That's what I need to do. Okay.
Like if you add the chlorine again, like you had it, and then try and add a hydrogen, even if the hydrogen's gonna have extra bonds on it, you should be able to release them. But I don't know if they'll let you add it. But it's try.
Everything.
Yeah.
I don't know what I'm doing now. I feel like I'm messing up like big time.
Where did it go? There it is.
Wait, which one is that? Did you look at it? Did you look at it already?
That's-
Okay.
Wait, Nicole, did we get the
So what are we supposed to
energy
do with
for the
that?
second
So we
finish as
just,
well?
are we not doing any more dissections?
Wait, because the negative 21.24 that was for the second.
No, because it just says
But did
to
we
do
get
it in the
separate?
most.
It's just,
I forgot to bring my. It just says minimize the, so to minimize minimal. I
Minimize the
because we
structure.
minimized it on here.
Uh-huh.
And
And
that's all we
record,
said to do.
record the relative energies of the staggered and anti-staggered.
Oh, it's a change.
Yeah.
Yes.
That is-
Okay.
You post it all the time.
So, let's try doing that.
I've seen it, I don't know why I didn't.
Okay, I'm gonna try to build the next week.
More than anything.
I didn't really want to.
Is there a
do
clear
that,
button?
Like, whatever milk.
I'm so
I don't
low.
have time to create a document.
I'm stealing your model.
Oh. You want a cat? Wait, get on the shelter cat.
I was saying yesterday, yeah, like Sunday.
What is happening right now?
I cannot wait.
Is there a
I have
clear-
two more days left of my
Yeah.
I'm gonna eat all the roads.
Where'd they go?
All the roads. What am I
Yesterday, I don't
doing?
know why, but I didn't realize until like, I like got in the shower and forward, and I was like, tell me what I've been in a bowl of like phone calls and working and like four communications all day. Like, I can't.
What do you do? See the living?
Yeah, I have to be a delivery driver. It's like, the like for sure. I was like, wow. I was like, that's so nice. It's like compared to Sonic, like, Sonic was always a mad.
I hated it for you. Like, it's like Cortez.
Oh my god, yeah, that was horrible. It's like literally the worst thing. I was like, why am I doing this? I think I got lucky with the people that I worked with because they were like super funny. But at the same time, I was like, I want to die.
Well, at least I feel comfortable.
I know, this like, I like it.
Oh, you get it?
Well, because I've been deleting it and redoing it every time. Now I'm trying to find the maximum.
I'm pretty taken.
Thing about failure is you learn a lot.
Oh, I'm not failing, okay, I'm learning.
Hey, I didn't say that.
Like, it's not that.
Okay.
It's not gonna like reward their bad ownership. It's
No,
like,
yeah.
I'm a good server and a hard worker.
225.
Okay,
I'm at
Exactly.
No, I just don't
I'm so excited to go with everyone else.
All right, so we're
It's not
gonna
the
come back with your
manager.
property.
Okay,
I
I
don't
would
think I have enough
So,
material.
for example, like.
because this is a minimal.
Do.
Is there a maximum?
So I bartend there and if, so if a fruit fly gets into a bottle, you have to just kill the bottle, you have to drain it and throw it away. Yes. They want you to strain the bottle, throw coffee filter,
Okay,
get
I
the fly out and
understand.
then put it back in the bottle. That's disgusting, it's illegal, it's against like all kinds of health codes.
Yeah.
No, I'm sorry.
Okay, I work in my.
Okay, that does look like a new molecule.
I know, we're stuck.
She's trying.
I'm trying to find, because we have to find the energy for the standard,
Oh, it says move on. I had to go and read the manual.
okay.
Because on an iPad, there's no Alt, Control, or Shift. If you, apparently I read the manual.
I just couldn't
If
figure out
you
how to.
hold Alt, you can rotate. So now I can go, Staggerati,
So she'd be.
Eclipsed. Staggered,
So it means,
fully eclipsed. Now, how do I read the energy from this now? As I said, I will go figure out how to do that. And of course, while I was away, students in my other class bombarded me with messages because their online exam was yesterday. And responders locked every single person out of the class.
Oh, no.
so,
Respondents locked my computer on Safari, so it's fine.
Mhm.
And now I can't use it.
Well, most people are being good, but one or two of them are panicking. All right, so do the next one, and we'll figure out what that energy
Okay,
is.
I was trying to do it, but I couldn't figure out how to,
1, 2, dichloroethane. So you pick carbon. Double click.
right. Wait, that's a lot. So is this how you do new confessions for the size of doors?
Yep. Mhm. Oh, it doesn't.
Oh, it
What?
doesn't matter.
Oh,
I like do the
God.
same thing.
That's an eraser.
So I don't even know.
yeah, this is.
Professional wire. We're gonna be using
Okay, there we go.
respondents for our multiple choice question marks.
That was the intention.
Okay,
That was the intention.
I need to acquire. Oh, this is not like laptop.
I know.
you do this easily.
Yeah,
It makes me feel a little bit better for myself. I got the other one.
I think it's.
Oh.
Okay. Wait, that's too many carbons. Isn't it ethane?
Yeah.
We've been here far too long, people. This was a.
Because of me.
40-minute.
Right.
I know, I have.
Just means we're learning.
Oh my God.
From Coach.
He said just.
All right, I'm gonna zoom through these.
I'm sorry.
It's okay.
Hold on, let me finish it.
You don't have to put
Yes.
hydrogens in.
Okay.
It knows. All right, minimize this. This is 1, 2, dichloroethane. What do you have to do to it?
Just.
Relative energies of blah and blah. All right. I don't have to make the energies yet. I need to go back and read them.
We have to do the minimum one.
Yeah.
Dang, I took it out of one and it didn't come out of the other. Yes. Oh, wait.
Oh my God.
Cyclohexane. All right, who has not touched the
Is
computer?
that muscles?
Come on.
I'm not sure if this is a more.
I don't want.
Dude, I feel like it's
To number 6.
I want.
Number 6, you can draw all 6 carbons in a ring, or you can pick a ring from the menu.
Wait, did you get the energy part? No.
No, I have to,
We're kind of mixing that.
I did one.
Temporarily.
with too far behind. I will provide you with that information.
Thank you.
Okay. No,
Try group.
no,
Oh,
no. Go to organic.
We're literally.
It says rings, rings.
Am I blind? There we go. That's not what we want.
One.
I want that one. It's like this one.
And then just double click. Not that.
One, two.
Oh.
wow.
Wow.
Wait, I want to.
It's not that bad.
That's
One was harder.
That's really good.
Okay. On one, three, and then on two.
What? Why would you do this?
You have to erase it. Is it really gonna do that?
I don't know if you can undo.
I Control Z step.
Is there like a button?
Edit, undo. Yeah. If not, the eraser is here.
It's just gonna take about a minute.
Now, back to organic, and then from that drop-down menu, no, what are we adding to the ring?
And
I
Echo
want a method.
We need to click on this for an sp3 carbon.
And then you just click it and see it. One, two.
Now, were you supposed to make the cis or the trans?
the cis.
You made the cis? Rotate to make sure you have. People looking at the screen, is that the cis or the trans isomer?
Let's take a picture.
Okay. So methyl is up and the ethyl is down, is that the cis or the trans? That's the trans isomer.
Oh, it's okay. How do you rotate it again? We double click on the line. What did you do?
I'm making it cis.
Oh.
There you go.
That's what's wrong, because that's cis, the other one's trans. But there's the chair.
Nice throws.
Why are you throwing?
It was right for you, my friend. No, I have avocados, I just have.
Okay, perform the confirmation analysis.
I'm gonna go to the store because look, I want this, what is this looks fine, that's portion, so I pictures. Jalapeno cheese bread.
That bottom, we're not
It's
all frosting
smashed
one.
up,
That
little
middle.
seasons, that. Little bit of
And then I'll
Parmesan.
show you.
cheese. Breaded, not great, this way.
That shows me the movie.
Then, the roll kicker, the baby is cut in half, but. On top. So good. Oh my god, I'm literally tearing up to you. It's a bacon if you have, oh my god.
Energy is 34,
Sorry.
4.767.
Skip
Wait,
the
did we
hardware
need-
scan.
Did we need that?
Sorry.
Wait, what was
It
it?
says to measure the energy required for.
Okay,
What was it, 34?
0.4767.
is it the kilojoules per mole again?
Yes.
My dyslexia was going crazy when we had these.
At two.
I will have my notes too.
You never go down to. You should. Just put it, I probably put it on this one.
So I can do it.
What is your? Did you order anything?
No.
Oh, man.
It doesn't say to draw it.
It doesn't?
It just says view in 3D, right? Minimize the structures and explain the position. We're on number 6, you know that, right?
Yeah. Yeah, it's.
Oh, sketch, oh.
The first word. I was like,
I don't wanna. I
I'm
said stairs, so. Okay.
I'm now stuck on what.
Can you do that? Else?
I like my stir fry sitting.
Anything or?
I'm not good at cooking. Like, I'm like okay, but I feel like it just tastes like.
Really? That's like my favorite.
I don't know.
I love it so much.
You know, what I really want
What?
hamburger steaks. And some gravy and some fries. Yeah. Gumbo with the broccoli sounds like that. Sounds like a really bad idea.
I don't know what we're doing today.
Probably 11 to 11.
I
Because
mean,
that's pretty
I'm
much all
kind
I
of
have.
happy about it though, because it's really.
Yeah. I am too, but.
So, what?
No.
JT asked for
Oh, yeah.
I was like, did you just ask for water?
Bro, I'm so
Oh,
shocked.
yes, 80 degrees out here. You don't know. Asking for water break. You don't get to do that.
Bro, she made me laugh. I was like, there's no way she just said that.
I swear, all this what?
It
Like
was-
considering our freshman year was like 107
Oh my gosh, 3 days ago, literally got water. in 2 hours. Okay.
I think we just need to change this.
Me and Emily and Hope talked about this, and like, I don't like the idea of like, oh, you're a freshman, like, shut the air conditioner off, like, I don't like that.
But there is a.
Every place.
What?
I got this minutes to go to the freshman, like, I don't know.
Oh my gosh, I just realized.
They didn't have
It's
preseason.
like worrying.
They're both on the,
Till
yeah,
like,
we're
like,
Mhm.
shut your mouth. Shut your mouth.
It's just like I'm comfortable with Elisa, I see how like she is.
Yeah, I think they
I
see
feel like
us.
it's looking her first, like,
Yeah, and I think they see us like joking around with coach and stuff, but like it's in time.
Dude, I think
Water
that's what he was
break,
trying to
before
figure
you
out, and then it was just like,
Yeah, like I want to talk most out of anyone on the team. No, I don't. I have pride.
he's
I
having
know.
trouble.
And I do joke around a lot, but like I don't want to do it. To be
How to
quiet.
do the.
Yeah, like more scrimmaging, like for the first time, like maybe.
Yeah. You know, also, they just kick. They'll just kick it. And it always works out for them. Someone always gets it. Honestly, we should just grow up.
That's why we just, he's like, I really like bullshit.
Two five dimethyl hexene.
Great pass, and then you go anywhere I want to, somebody else does it, and like half that pass, and it still gets it, I'm like, yo. But it's like, I'm missing that.
Yeah.
So it's done.
Definitely.
Yeah, okay, I was gonna ask if you make a collective decision to skip
I
out.
just don't, I didn't sketch it, so that's my thing.
So wait, do we have to run around?
No, I think you just have to turn this in.
Got it.
How many,
Did you
guys have
to make small cottages?
You have to do the, these, you have, like, you have to do the different questions.
oh, just the name of the nutrition?
Yeah.
Okay.
But there's like 4 different ones, but 2 of them are the same.
I think
thing.
that is very- You should.
I mean, I think
Casey, that's like,
the hugging.
Hope had to leave, so Casey filled in for her the other day. Oh my god, I miss Casey so much.
Yeah.
She kind of like good.
I know. I forgot how much Trish was. Like, because
so good.
I would play with her, like, for 4 years, like, in high school.
Really, she's so good. Like,
And she was on my side, and she started going towards me, and I was like, how big? She was She's a joke. No, she's so bad. And Callie trains.
Oh, Kelly's easy for us too. She's in really good shape.
Yeah.
When she was doing the group stuff, I was like, oh my god, dude.
I just kind of-
I'll see if I can send you the table.
Okay.
In the app, it just does it. In
Yeah.
the software, you have to dive through menus to get to it. I just read the manual and it looks like I have to go, what is this? That's the CIS now. Okay, it looks like I have to go build calculations. I don't know, I'll send it to
I
you.
wanted to like, I wanted to go ask her, like, if she's in.
Oh, it did show up.
I wonder if maybe she's not there.
And then it's weird because we already have like another 100 points that we're going over.
Yeah.
I feel like she did. I mean, she should be able to do it.
We'll send it to you.
Okay, that's fine.
Sorry about that.
No, it's all good. Have a good day.
Oh,
Bye.
Should throw the iPad. So, if you're still hanging in there at the end, I'm going to send a table of energies to you. Today, the software that we were using is not the regular piece of software that we normally use for this lab. And instead of just displaying the energy, we have to go dive for it through menus. And we'll figure that out and send it.